aging should be treated as a disease. It's a legitimate medical goal to get rid of it. Just like pain. Pain is totally natural and it's quite useful in many situations, but you want to regulate it. And hence, we can take painkiller drugs. So we should be taking aging killer drugs to get rid of the aging, and we might want to take stupidity killer drugs to get rid of stupidity.
Thank you for joining the Transform Impossible, which is India's first future tech meets sustainability podcast. And today I'm delighted and honored to have Mr. Anders Sandberg, who is a researcher, science debater, futurist, transhumanist, and an author. He holds a PhD in computational neuroscience from Stockholm University and is currently a James Martin Research Fellow at the Future of Humanity Institute, which is founded by Mr. Nick Bostrom at the Oxford University, and a Senior Research Fellow on the ERC for Unpredictable Impact. Mr. Sandberg's interest and research centers around global catastrophic risk, cognitive biases, cognitive enhancement, collective intelligence, neuroethics, public policy, and assessing the underlying science and capabilities of future technologies. So it's a pleasure and a total honor to have you on the podcast. Really appreciate you giving time and being part of the show.
Thank you so much for having me.
3 years back, I saw this talk of yours, which was on TedX. It was titled Humanity on the Edge of Extinction. What has changed since the talk, and do your views remain the same?
So humanity has certainly been having a big crisis since I gave that. The COVID-19 pandemic has demonstrated both how unprepared we were for even a kind of disaster we had experience with, but also demonstrated some amazing resilience and abilities of humanity, that we could very quickly understand the virus scientifically and start working on vaccines, but we actually figured out ways of coordinating fairly drastic changes in many societies and actually could use that to hold it back. But at the same time, appalling failures of science and leadership in different countries. One can probably write a very big book about what we ought to learn from the different mistakes different countries did. But overall, my thinking has not changed fundamentally. Humanity going extinct or losing its potential would be tremendously bad, the worst thing ever. So we need to work very hard to avoid that happening. I'm also an optimist. I think we can do that. I think the future is positive and worth saving, and I think we can have a positive impact. The various risks, they change a little bit over time, depending on how the world is. When you get more sane leaders of the nuclear nations, the risk of nuclear war goes down. When people invent risky new forms of biotechnology, the risk goes down. So there is almost like a stock market of risks, and we're somewhat uncertain about the value of some of the risks even. But I think we're taking some good steps, actually, in coordinating better against some of the big threats.
You said that obviously the entire world was caught unprepared, but yes, there was what came out, that larger resilience of people, and we all came together. I guess that's the reason we have a vaccine, which is in some sort of a world record of sorts. It happened in maybe 6 or 8 months. And that showed that the power of collaboration, and when we all get together, we can really, build great transformation. Now, you spoke about extreme risk. Now, extreme risk, at least here in India, hasn't got the attention that it deserves. Neither, not even a single organization here in India, which is trying to peer into the future, probing the possibilities of what could go wrong. So, do you think each and every countries, at least post-pandemic, should have an organization or a team that works towards predicting, understanding, and possibly mitigating the future catastrophic scenarios that might happen?
I think that would be a very good thing, because right now there are very few research organizations in the world that try to deal with the biggest global risks. You can certainly find a particular organization dealing with particular threats, and we have a lot of infrastructure for pandemics and other disease outbreaks. We have an infrastructure for handling climate and nuclear risks. But the number of researchers up until recently who could handle risk from artificial intelligence, you could easily seat them in a lecture theater at a not too large university. And I think it's also important to have these groups present in different countries because the experiences are also very different. It's quite often important to be able to go and advise local politicians and do that from a perspective that actually makes sense on the local scale. There is a risk that if we work on the global things on a very abstract level, it's going to be academically interesting and maybe even in theory important, but it's very hard to tell a politician what they should do in a crisis. Then, of course, you have to think about tactics and strategy. Predicting big disasters is sometimes possible. Sometimes you can know centuries ahead that an asteroid will hit Earth. That's very predictable, and the real problem is just preparing something to handle the problem before it happens. In the case of pandemics, we knew perfectly well that pandemics will happen. We just didn't know which one and when. And that is a fundamentally random factor, which unfortunately we will probably not be able to handle. What we instead need to do is react quickly. As soon as we notice something that starts spreading among humans that seems to be new, we should kind of drop what we were holding and immediately start working hard on fixing that. The real problem is, of course, the future things that don't exist yet but could become a threat. Designing artificial intelligence so it's safe and value aligned is really hard. And we haven't got that powerful artificial intelligence yet. And we need to make that safety work while we're developing more powerful AI. The problem is, of course, if we get powerful AI before we have safety, we are going to be in trouble. And most of the people developing better AI generally tend to think that they know what they're doing. This is intended to be safe. How could you claim that there could be a problem here? So there is a fair bit of debate and politics you need to do. It's not just the politicians that need convincing. Quite often it's the scientists too.
Right, yeah, very true. Because, at least, when you're talking about future technologies, you mentioned about powerful AI. We are so caught up with our own things or day-to-day life that we have lost the capacity to peer into the future. It's not that we've lost the capacity, but then we don't want to look beyond a certain time because we have a certain timeline, and that's how we humans think, or we've got so used to thinking. We don't actually look beyond. Almost all the technologies are converging, and it's largely, I think, I could be wrong, it just might go out of hand the way things are going, right from artificial intelligence to synthetic biology to nanotechnology to virtual reality to quantum computing. These are tools which are no longer the tools of yesteryears, like a fire or thing. These are tools which are extremely transformational. At one side, it can create huge transformation. It can bring changes all over the world. It can make a spacefaring civilization, but it can also be the cause of human extinction. But somehow, I don't think politicians, governments, or organizations are taking that seriously. Do you think that that we should start having serious conversations and not just maybe like a isolated conversation having in a single nation? Should there be like a global concerted effort of the growth of these exponential technologies and what it could bring, the transformation plus the disruption?
So I think the problem is, as you say, our human thinking tend to be located very close to the here and now. Indeed, psychologists have this concept of construal theory, how we think about certain things and how they change as they move away from us in time or space. To many people, the future is very fascinating, but it's like television. It's something you hear about, you think about, but it's not really something you plan to be in. On the other hand, many people do care about how their house is going to be in a few years. They know I'm going to be sitting in that house, and if it's leaking, that's bad. On the other hand, if a singularity comes and it's a bad one, well, that's kind of a science fiction movie to me. Getting people to change their view here requires them to be able to visualize that actually the future hangs together, and many extremely strange things are likely to happen over even a normal human lifespan. After all, most of us have experienced that. Even the COVID pandemic is kind of a good example. Here we have this global, extraordinary thing that we solved in a totally new way, and we all got to experience it one way or another. I think most of us would have wanted to avoid it altogether, but it's a demonstration just how weird things can be. Indeed, it made us a telecommunicating species. Suddenly, many of us are now globally working over Zoom. We're coordinating healthcare. We found that we actually didn't need to travel as much as we thought. I was wrong about this time last year when I was claiming that, look, if you stop people traveling, that's going to totally crash the world economy. No, actually it didn't. Okay, I was totally wrong about that. Now, the really interesting thing about this is over a future lifespan, we should expect more things like COVID, maybe some equally positive as this was negative. And the problem is, of course, most of us just don't know how to even imagine something like that. Now, the problem is making a global discourse about the future is going to be really challenging because people think about time and future in different ways. Indeed, we might have very different values. While I really love the idea of converging technologies and using technology together with humans and becoming something more than the current species, other people say, that sounds bad, too risky, and even evil. So the real question is, how do I get to have a nice discussion with them so we can at least agree on some of the things we both want to happen? And I think it's doable, but it's going to require innovations in policy making, governance, and institutions, and maybe telecommuting too.
Right. So this COVID obviously has somehow been a catalyst for frontier technologies. I mean, what was taking a long time suddenly everything has been accelerated. People have got to know the importance of remote work, remote healthcare, remote education, and geography has suddenly become history. You don't really need to be at a specific space. If you have good connectivity, you can conduct business and you can go about doing a thing. So yes, there has been a shift of perception. How we work is being transformed. We no longer need to travel. Get stuck in the traffic for hours. You could be productive. Use those times. So there's some fantastic things that have happened. Obviously, the downside has been that we've all been confined to our homes for the longest time, and it's about time that we need out go out because I think humans are social creatures, and when there are things that we end up doing, when we see, meet, so pandemic, talking about the pandemic, people are claiming that the virus was leaked in Wuhan Lab. Would you like to talk a little bit about that? Because I think Jamie Metzel is someone who's been kind of driving that conversation that it's been leaked in Wuhan Lab. Would you like to address that?
Yeah. So the problem here is that the lab leak theory is it's actually something that could have happened. And then the problem was people immediately turned it to politics and argue that even believing it is believing in a conspiracy theory, etc., which totally misses the point. Lab leaks do happen. Over the history of modern medicine and epidemiology, there have been many examples of lab leaks causing damage. Over here in the United Kingdom, we had 2 outbreaks of foot and mouth disease, which hits cattle, from the same research lab, and one after the other. There has been outbreaks where people have been infected with smallpox from labs. And indeed, there are some arguments that a particular flu pandemic might have been an escape from a lab. So we actually have good reason to think that lab leaks are entirely possible. Now, was COVID-19 a lab leak? That's going to be hard to find out. And unfortunately, the politics makes it harder. But I think the general conclusion we should draw as a world community is that, even if we will never find out, we should probably treat it like that. We should probably decide that, lab leaks are probably very dangerous and we need to become better at that. There is some research that is done on viruses that I think might be too risky to merit being done. It's so-called gain-of-function research. So many people are interested in whether different viruses could easily become pandemic. And one way is to engineer them to become pandemic, and you see how hard it is to make them do that. You can even do it using genetic engineering or even evolving it in the lab. And many people, including a lot of virologists, think that this is stupid. The benefits from learning about it do not outweigh that we now made a pandemic virus that we have in a test tube. That's not a good thing to end up with. So there are some forms of knowledge that as a side effect produce bad things in the world. So there is, I think, an important conversation to be had about how do we actually safeguard these labs. So similarly, we might think about the International Biological Weapons Convention, which unfortunately has a minimal budget. Literally, as somebody pointed out, it's smaller than a typical McDonald's franchise in America, budget-wise. And they are the ones supposed to keep an eye on how the governments are building bioweapons. That ought to be increased and turned into something useful. The problem is, of course, that we see here that national agendas and even just national pride quite often get in the way of the sensible thing of sharing information and actually trying to make sure that everything is safe.
I guess there has to be a conversation with the larger public. People do not know what gain of function is and why do biotechnologists need to tinker around with it. If the conversation was there, if people were aware that this is something that we're trying to get ahead of, so in case of a serious pandemic, we know that we can solve the problem, should have it been the dialogue. But somehow, I guess the government, the larger organization, institutions, so far have treated people in a way where they feel that, oh, they do not need to know everything. But I think that needs to change. If that changes, then maybe awareness, I guess, brings about more understanding of what it is and why do we need something like this. At this point in time, the reaction on Twitter is bonkers. They're like, oh, we do not need this. So that I believe definitely is wrong. And yes, if lab leaks do happen on a regular basis, then we should definitely probe into the security. Why is it happening? That is a concern, because now synthetic biology, genetic engineering is getting into the hands of students. It's getting into the hands of rogue organizations, and it's no longer rocket science. It is a tool. If you spend a certain time, you will understand the source code of life and you will be able to kind of tinker around with it. There are people who are doing fantastic things with genetic editing. There are, though there is a war going on for patents at this point in time for the ones who have founded CRISPR genetic editing. But if we kind of understand it, there are so many genetic diseases that we will be able to take out from human race. We will be able to take out pain and suffering from the human race. But somehow the conversation is not right. The conversation is, oh, we can do designer babies. That goes a little ahead. If we start from the scratch saying there are millions of people in the world who have problems, there are millions of people who have neurodegenerative diseases, who cannot move and are confined to their bed all their life. If the people who have problems can be given a way to solve the problem, I think that would be a proper narrative. Now with genetic editing, there is two forms of editing. One is somatic and one is germline editing. Could you talk a little or explain what these both are, what they do, and which do you think, according to you, is the way forward?
The idea with gene editing is that you take a piece of DNA, the coding for something that you want, and put into the right part of the cell, or that you remove a part of existing DNA, so you turn off a function. Programmers would recognize it almost like putting in comments or writing extra lines of code. Now, it used to be that people put in this into plasmids that were then put into viruses, and then you infected cells, and hopefully the virus would then put the gene in the right place. You used a virus that wouldn't reproduce, and this way you could get the cells to express the new instructions. More modern methods like CRISPR-Cas9 use a much more sophisticated method of actually putting them in the right spot. And in both cases, you can do it either on the cells inside the existing body, and then you get somatic engineering, where you can change the properties of some cells. But only those cells that you manage to infect with the new gene, and maybe they will then later divide, so you get more of them. But generally, it's only a handful of cells that get transformed. You could also do it, of course, with the germline cells, the cells that are just when the sperm and the egg have merged. And at that point, the change is going to exist in every part of the body, in every cell. This is potentially tremendously powerful because it can change how the entire organism develops. On the other hand, somatic gene therapy is very convenient because you can use it on existing people. And they can even say, yeah, I do approve of this. While it's very hard to get that approval from an embryo who doesn't exist yet. Now, just getting back a little bit to the thing you said just before about how people think about the importance of things like pandemics and gain of function research. I think literacy is very important here. A lot of people don't know what DNA is. Indeed, you can ask Americans and find that a sizable fraction of Americans say, I don't want to eat food that contains DNA. The fact that they and their food, of course, is full of it, they don't know that and they don't think about it. And if you explain to them, they shrug. It's not part of their normal life. But if you have a good education, you have some sense of what trustworthy source of information, you might have some opinions. That doesn't necessarily mean that you become pro-genetic engineering, that you think that this is a good thing. Indeed, many people become more polarized the more they know. But at least we can argue about things that exist in the real world rather than just made up stories. The problem with genetic engineering is that many people now immediately start talking about the design of babies. While, as you pointed out, there are many genetic diseases that we might want to prevent. And that's both easier and ethically unproblematic in most cases. So the interesting part here is, why do people start talking about designer babies? And that is partially because nobody really cares about the technical details unless they're really into biotechnology. They think about the meaning. How does this change the world? And having people not get certain diseases, that's nice, but it's not anything that really transformed the world. So people start talking about the designer babies. We had the same conversation in the late 90s about nanotechnology, which is about a hypothetical technology that manipulates atoms on the atomic level to build materials and do useful things. Many people were very concerned that this could lead to dangerous self-replicating machines. The originator of nanotechnology, Eric Drexler, he kind of talked about it and then pointed out why this was not a problem. Already in the early 90s, he had even good arguments for why you don't even want to use that technology that could be dangerous because others would be much more useful. But as the field developed and you got professors of nanotechnology, people were bringing up their hopes and fears to them. And the professors didn't have a good way of responding because they could talk about atoms. They knew about nanoparticles and what they did in the test tube. They didn't have the vision of building actually an infrastructure that could transform atoms, which was the long-term goal of Eric and others. Instead, they were doing totally normal science and got very upset when people said that it could be dangerous. Just like today, and AI research get very upset when you say that, look, what you're developing could become quite dangerous if it was much smarter. And they will say, yeah, but it isn't smart, so I don't need to worry. And you're just threatening my funding. So in the case of nanotechnology, because people inside the field were mostly doing technology and not thinking about the vision, what is this for? What should we do with it? They ended up being very bad at responding to people's concerns about risks, which made people worried. And of course, they also want to kick out the visionaries because they seem to be related to the people talking about weird risks. And we have the same problem in many parts of science, that you can do good science about a tiny, tiny little thing, but you also need to know, what is that tiny thing for? Is it intended to be part of a new healthcare system or a way of getting renewable energy or a way of transforming mankind? Actually talking about those visions is important, both because you need the motivation to get out of bed every morning. And it's hard to get out of bed if you know that my task today is to purify a single protein. Who cares? If you know this is a tiny little task, but is part of a road to defeating disease, that's much better. And that also means that we can talk about the values underlying it. The designer baby discussion is really about, what do we want reproduction to be? What do we want ourselves to be in the future? And yes, we don't have a technology for that, but that's an important discussion we should be having, even though we can say, yeah, most designer babies are far in the future. But yeah, we need to have some consensus. Otherwise, we're going to get real trouble when they start arriving.
You spoke about nanotech. You spoke about synthetic biology. Is there a connection going on between atoms and molecules and DNA? would you like to talk a little bit more about that? Because, when you talk about atoms, you talk about the entire universe. Everything is made out of atoms, and that's the outward universe. And then you go inside and we are cells. It's all molecules and things like that, and they function because there's trillions of cells which is firing these electrons, and that's the reason. Is there a connection going on between the outside world and inside world?
In many ways, the separation between outside and inside world doesn't exist. At this moment, I'm breathing in atoms from the atmosphere. I'm losing skin cells that become part of the dust in this room. We're kind of open and transparent in some sense for the outside world. Of course, our immune system is doing its best to keep us separate from the outside world. And on a deeper sense, of course, our cells, everything is made out of atoms. It's just that life is slightly different from non-living matter. Not because it's made out of
I'm sorry for interrupting, but are we biological or electrical in nature? Because our cognitive structure, it functions because of electrons, and so does a cells inside, trillions of cells. So in some way, are we the artificial intelligence that we're trying to search or trying to build?
Well, artificial intelligence is in many cases that we try to make a mirror image of ourselves. Quite a lot of discussion about artificial intelligence is concerns about what humans are like, and we're trying to make something that is like humans. But the most successful forms of artificial intelligence doesn't look at all like humans. If you think about a search engine like Google, that's not like a human mind at all, yet it's doing some intelligent things, but in a very alien way. Now, the interesting thing about biology is that we're highly structured matter. Every cell in our body has an organization which is simultaneously rather messy. A lot of random things are going on. There's a lot of noise, yet it's also robust enough to survive. And it can take up nutrients, it can produce energy. That works well. And this is why we can persist so well over spans of decades, because we are taking in energy and nutrients, and we're dissipating that as waste heat and waste. And that allows us to keep the entropy of our cells low, so we function. This is kind of unusual compared to most things out in the universe. Stars certainly burn hydrogen, but they don't get a complex internal organization. They're relatively simple objects. Most planets are just bundles of rock or gas. There might be interesting, complicated patterns in the cloud, and there might be hurricanes on them, which are to some extent self-organizing things, but they're less complex than even the simplest bacteria. The interesting thing about our kind of life is that we are also trying to make complicated material structures. We built the internet. We built the International Space Station. We're producing microchips that have literally billions of components on them. There are actually more different things you can buy in the Amazon catalog than there are known species of life on Earth. And yes, each book and cell phone maybe doesn't count as much as a flower or a tree, but we have generated tremendous diversity in the unliving world too. Indeed, some people are talking not just about the Anthropocene, that we are a kind of a geological force and messing up the planet, but also that there are many anthropogenic minerals. We're producing new minerals that didn't exist on Earth before humans. We're creating very weird environments that didn't exist, and life is adapting. Sometimes in very strange ways, like some birds in Mexico City have learned that cigarette butts, because of the nicotine, are very good at fending off parasites. So they're using cigarette butts in their birds' nests. And we humans who kind of recognize the health problems might be a bit disturbed by that. But to the birds, this is a new natural resource we can exploit. So the fascinating thing is that deep down, it's all about atoms interacting. But life is about setting up situations so fairly unlikely reactions happen much more often. We have enzymes that may catalyze chemical reactions which would take very long time outside our body. We have various compartments that make the reactions go even faster. And as intelligent creatures, we're reorganizing the world into unlikely patterns. It's such a situation that if I press a button on my computer, a complicated pattern of computation takes place, spreads out across the world, across the internet, and might be producing signals in somebody else's computer, or might order something from a warehouse far away. If I press a different button, something completely different can happen. And this is, of course, how I think intelligence and life can actually reshape the universe. individually we are very weak. Individually, each cell is very weak and can't survive very well. Together, we can actually grow exponentially, both in population and skill, and actually transform the world. So I do expect that in a few billion years, the universe is going to be totally reshaped by life that have started Earth and maybe other planets, led by intelligences that can actually make spacecraft get off the planet, to build the habitats so life can survive the harsh environment and figure out whatever it needs to be done, build the mega scale engineering or move planets and stars.
Lovely. How cool is that? You are a transhumanist. Would you like to give an overview about of what transhumanism is?
Yeah, so transhumanism is the idea that we can improve on the human condition. Normally, people talk about the human condition and say, yeah, to be a human means to be mortal, to age, to have heartbreak, there are certain emotions, and there are some things we just need to suffer and maybe hopefully learn from. Now, humanists in the Western tradition were saying we can probably improve the human condition a bit by doing rational thinking, education, reading good books, maybe having a bit more democracy in schools. So transhumanists say that's great, but we might also want to stop aging biologically. Why should I actually have working memory that can only handle 5 things at the same time? What about 50? What if we could actually extend our bodies and minds to do entirely new things? Either as personal expression or to just function better at the projects we have. So transhumanism is about questioning the human condition and asking, what's that good for? Do we really need that? And in some cases, testing, can I actually get away with changing it? And in some cases, this might be a very good idea. I do think slowing down aging, for example, is one of the morally most important things we can work on. In other cases, like removing sleep, it might actually be a bad idea. There seem to be good reasons why we are sleeping, and it might be hard to optimize that. But again, I'm very happy if somebody tries it out, tries to see what happens, and then we can learn from it.
For the first time, I think we humans are asking questions which are way beyond, maybe it's a hubris, but we are tinkering with the source code of life, and we are finding ways which we can be optimized. You mentioned about slowing down aging, and there are so much research going on, and the world would look fantastic if we can manage to do that, because aging is such a problem. You see your loved ones dying and dying nicely, dying confined to the bed with the bed sores and so on and so forth. If we can tackle that I think would be the first step of kind of understanding ourselves. I mean, there are 2 things I think we need to understand really. Though we have done the entire human DNA, we understand that, but we don't really know what the DNA does, and so is our cognitive structure. We want to know, but we know so little of brains. I mean, if we know both a cognitive structure and entire DNA and what it actually does, what each of the DNA when it expresses, what it does to a body. I mean, once we understand that, I guess mankind would be completely transformed. We'll be going from Homo sapiens to Homo Deus, as they say. So I'm excited for that world. What would be the timelines, according to you, that we, the humans, start seeing benefits of these things that you spoke about becoming realistic? Right from your synthetic biology, your age reversal, or diseases being, taken out of the. When do you think that these things will start becoming realistic? So people say, oh, these are not science fiction, and because right now there is a lot of speculation, possibly negative expression of people, because there is obviously a certain section of people which will always say that you're tinkering with and you're trying to play God. But I guess once we start seeing the goodies of that, we can actually have age reversal and there's no bad outcome of something like that, I guess things will start looking better. What could you kind of give us like a timeline or brief where from when do you think humans will start seeing these transformational changes to mankind?
So I think in some sense we're already seeing it. But the problem is, as William Gibson said, the future always arises in the wrong order and at the wrong speed. It's not evenly distributed. So on one hand, when I think back at how I envisioned the future when I was a kid interested in science fiction of the future, I didn't imagine internet. I couldn't imagine how that actually transformed the world, because now everybody is 1/7 of a second away from each other. We have access to the world's knowledge at our fingertip, and many things are totally transformed by that and by smartphones. On the other hand, in the 90s, when I was involved in setting up Transhumanist organization, we were very cheerful. We are soon going to have nanotechnology, and it looks like we're cracking the biology of aging. And then we discovered that nanotechnology got delayed because of sociological reasons. And the biology of aging, the fact that we're getting better and better at not just understanding aging, but even modifying it in the lab, doesn't necessarily mean that you can run a successful medical company selling a drug to your old mother. Because that transition is also a complicated and hard one. And that took much longer than we had expected. So as a middle-aged transhumanist who started to have gray hairs, I'm kind of hoping that it speeds up. But it takes a lot of time. Many of the really transformative technologies, they creep up on you, and they're much more slow than you expect them to be. So in the 1990s, I was working on virtual reality, and we were very optimistic that this is going to be fantastic and transformative, and it didn't go anywhere. It was kind of embarrassing after a while. I needed a mainframe computer to run my virtual reality system, and it was not terribly impressive. Then 20 years later, smartphones started showing up, and they have good graphics processor. They are more powerful than that mainframe computer. And people started doing virtual reality by even putting cell phones in glasses, because the accelerometers, which were another important part, had of course been well developed by that, first by the military, then by space people, and then by people using them in cell phones. So what happened was virtual reality is still not taking over the world. We're still looking for what it would be good for, except maybe games of various kinds. But it's much more doable. So many of these technologies are going to creep up on us. So in some sense, we already have a CRISPR babies because of a Chinese professor who actually did some ill-advised gene therapy. And they were kind of deliberately enhanced it. It was not just curing something, it was enhancement. But it's also likely that the reaction against that is going to mean that it's going to take a long while before anybody actually dares to do it in most cultures. Also, we want to demonstrate that it's safe, because parents are usually very conservative when it comes to the children. They don't want any risk to the child. They want to be guaranteed that this is not going to be harmful in any way. If there is a risk of a genetic disease, selection and other methods can be used, and that is still worth it compared to the horror of a disease. But for enhancement, I think people are going to be much more conservative, I think. On the other hand, I used to be rather pessimistic about gene therapy. I used to think that, this is somatic gene therapy is nice and it's going to help some people, but I really doubt it's going to be transformative. That has advanced way more than I expected. I'm kind of impressed by how well it works. People have been using optogenetics to make nerve cells light sensitive, which might allow new forms of neural interfaces. Indeed, people are working on applying this to give back eyesight to blind people. So what I'm seeing is that there might be other technologies that overtake germline gene therapy that have much smaller ethical problems, or much safer in the sense that we can test them out, have people report back what happens, and don't do them if they turn out to be risky. And you can combine them in interesting ways. So the great breakthrough of 2020 was, of course, the RNA and vaccines. People have been talking about that for ages. But using messenger RNA in order to control cells and produce a vaccine, that's great. But you might be able to use it not just as a standard vaccine against diseases like malaria, but people are talking about modulating the immune system, which is really interesting, because in my family there are some people with autoimmune diseases, and they would really like to be able to control what cells the immune system wants. So this shows that we are getting other technologies much faster than we expected. So this is my roundabout way of saying, this is why I don't think my timeline is going to be worth very much. I think that within 10 years, we're going to see much better examples of these technologies. I think the CRISPR babies are probably a generation away. On the other hand, we are probably also going to see other applications of biotechnology that are right now kind of unusual. For example, the gut microflora is quite important for our well-being and our health. You might genetically modify that one, which is much easier to do, of course, than modifying the whole body, which might mean that we might, instead of taking drugs, we might just send a signal to modified gut bacteria to produce the drug. The real challenges are always going to be the kind of social, cultural, economic. Pharmacology companies, they can't make any money from making an enhancer drug. If a drug is intended to make you smarter, they can't sell it. So there is no point in them even researching it because it's no disease. If you could find the disease label for not being very smart, or even better, if one of the drugs seemed to work for that and they could get some doctors claiming that now it treats a condition, then they get there in. But here we have this legal system for medicine that says, yeah, you're only allowed to use drugs to cure diseases. And then defining diseases typically is very limited. This is why many people dealing with anti-aging argue that aging should be treated as a disease. It's a legitimate medical goal to get rid of it. Just like pain. Pain is totally natural and is quite useful in many situations, but you want to regulate pain. And hence, we can take painkiller drugs. So we should be taking aging killer drugs to get rid of the aging, and we might want to take stupidity killer drugs to get rid of stupidity. But that is going to depend on a lot of political and economic factors, which are very hard to predict. But I would guess that given the power we have in artificial intelligence to design new molecules, given the power we get from nanotechnology and protein engineering and DNA engineering to make these ones, by mid-century, we're going to have a lot of tools. And at that point, it would be very weird if not some of the tools at least have been approved. So I think I'm kind of optimistic that I'm not going to get that much more gray hair.
Yeah, so yes, like you rightfully said, that the technology somehow creeps up onto you, and what is creeping up onto us at this point in time is artificial intelligence. Everybody is talking about it, though it's in a very narrow space, but it's growing exponentially. It's rearing up its head in spaces like with what people are doing with GPT and so many awesome, really, really awesome things. Now there is a certain group of people thinks that machines are going to get human level intelligence. They're calling it artificial general intelligence. What are your views on that? Do you think that is possible? And if it's possible, what would it take to get to AGI? Who do you think are asking the right questions in building AGI? And when do you think this would be most likely?
So the last question is perhaps a good starting point. I have no idea. And it's a little bit like the timeline question, but this one is worse because it's about something that's very driven by pure ideas. Most of advances in artificial intelligence have happened because people have a brilliant insight or an idea. And that means that you can usually not predict when something is going to happen because if you knew when the idea would arrive, you would already have the idea. Some of it is driven by the growth of computing power and that we have a lot of data on the internet. But the progress of artificial intelligence is very unpredictable because of these ideas. Indeed, in the 1990s, when I was a student, I was studying neural networks, and I was asking my advisor about deep neural networks, and he told me, no, they didn't work in the 80s. It looked like a dead end. And back in the 1990s, it was a dead end. By 2010, they started working because it turned out that you need bigger computers, bigger networks, and more data. And suddenly, things worked wonderfully, and that has led to the current revolution. So the problem is, even if you're in the field, you might get surprised by it. So this is why I don't think we can predict when we will get artificial general intelligence, because it's so linked to ideas and things that we know we have in the past been bad at predicting. On the other hand, is it possible to get general intelligence in computers? That is an important issue. I think it definitely must be possible because you could argue that you could always simulate an entire human brain, at least hypothetically. And that's general intelligence. So the software simulating that would behave in an intelligent way. At this point, a bunch of philosophers will disagree with me and say human brains cannot be simulated, and we can have a bigger quarrel about that. But I think the general thing is nobody seriously disputes that you could have general intelligence in computers. What you might argue is that might take a long while. It might not even be very good business to do it. After all, many companies are making very useful AI for particular purposes, and that's what you want. You might even want to have a fairly narrow AI that helps you with household work. It needs to be general enough to understand how to do the dishes and cook a cup of tea, but you don't want to discuss philosophy with it. I think at some point, however, that household robot, you want enough general intelligence, you can give it new orders, or your household might be organized in a different way from mine, so they need to adapt. You probably need general intelligence to function well around humans. It's a completely different thing if you want to make an autonomous car that works very well. Now, I think we are going to see a lot more powerful, narrow artificial intelligence, which is itself quite transformative. It seems like most perception tasks can probably be automated relatively soon. It's an interesting question how much manual dexterity tasks can be automated by robots. That's harder, but we see good advances. We're also noticing that many of these narrow systems can fake general intelligence really well. I like to say that GPT-3, the language model, is dumb as a pile of rocks. It's only repeating essentially what it has figured out by reading the entire internet. But that's usually good enough to give answers to questions that are actually fairly reasonable. It's good enough to make continuation of stories that are actually readable. It even managed to sometimes make good jokes. Normally we would say to make a good joke, you need to understand humor. You need to actually understand what you're talking about. This is just manipulating words. But given that it knows how humans have manipulated words, it can kind of extrapolate that this is probably what a good joke would look like. So it might turn out that a lot of fake intelligence might also work just as well as general intelligence, which might be very humbling for us humans because we like to think that we have real intelligence, even though I think many of us do fake it every day.
Yes, at this point in time, obviously GPT-3 is just lacks understanding. But do you think that intelligence is emergent in nature, and eventually, when you keep on loading that maybe possibly version 20, 30 could have a aspect of possibly general intelligence coming in? Is that the process of intelligence? What is intelligence? And what could be the possible roadmap of creating?
So Shane Legg, one of the founders of Google DeepMind, he wrote a very interesting paper about the definition of intelligence. He wanted to define intelligence to write his PhD dissertation, and he got annoyed by the psychologists having lots of very different contrarian definitions. So in the end, he summed up what he had learned by reading their works as intelligence is the ability to achieve your goals well in general environments. He also has a more mathematical version of this that he could then apply to his research. Now, the interesting part here is it involves having a goal. You're trying to solve some particular problem for some reason, and then you figure out how to solve it in the environment you're finding yourself in. And of course, a truly intelligent general agent, you drop them off on an alien planet with a task, and they try to figure out how to do the task. And if they're really intelligent, they do it well. Now, there are limits to this. Humans can't solve all kinds of problems. There are probably some planets where the problems are impossible for humans to solve. Indeed, one can mathematically prove that in some sense, the set of all possible problems is too vast for any intelligence. But if you have an intelligence that is doing really well on Earth, that's kind of important anyway. This is a special environment. It was 3 dimensions and an oxygen atmosphere. That is very specific, and maybe some forms of brains are better than others. Now, the thing here is solving problems. That means that you need to have some form of goal. And typically, we make goals for our machines. We have autonomous cars that have as a goal to get from point A to point B as fast as possible, as comfortable as possible, and without hitting anybody. That's roughly the goal. It's already fairly complicated, and then it needs to deal with this unknown world. In playing chess, the goal is very simple. It's much less clear what the goal is, for example, of being a good human. Even if that is one goal, it might be many different kinds of goals. So one challenge is setting up goals in the right way, so we can actually make AIs that do what they should be doing, and not just what we tell them to do. Because there are endless fairy tales about the problem of wishing for things without thinking them through. And machines are very good at giving us exactly what we asked for. But there is also this interesting thing that you can get emergent goals. A chess playing machine might find that it's better to have extra memory in order to play better chess. And an autonomous car might figure out that if it can ignore certain traffic signs, it's going to get to the destination faster. This can be very dangerous. So you want to find ways of avoiding that. You want systems that might actually be able to reflect on their own goals. And then you get closer and closer to what the philosopher might say, that's a moral agent. The car can actually start thinking about what it's doing and notice that this is a right or wrong way of doing it. We might not want to build cars that we care about morally. We might just want to keep them as tools. But there might be other systems we definitely want to be moral agents. Now, we are bad at even telling whether other creatures in the world are moral agents. So we have a real philosophical and practical problem here. But I do think that we might see a growth towards more and more general intelligence because we're also putting together different systems and modules that have already been trained. GPT-3 is just a language model. It just knows how to predict words in a sequence of words. And that accidentally produces a bit of intelligence. You might combine that with a vision system that figures out what it's seeing. And you could combine that and have something describing in stories what it's observing. You might combine that with some other software to control a robot, and now you might have a poet robot moving around. You can hence get a lot of interesting interactions, and at this point, we don't know how to debug these systems. We don't fully know what they're going to do. And that is, of course, a real problem if you care about safety. If you want a machine that does exactly what you designed it to do, it cannot learn. Because a learning machine can learn things that you didn't design it for. So you might say, I'm going to put in the right kind of goals, so it's going to want to do the right thing. But again, you need to check that these goals doesn't have unforeseen side effects. And that is a real challenge. And this is why I think artificial intelligence ethics is not just about the ethics of what robots should and shouldn't do, but also how do you design ethical systems? How do you design safe systems? Or even how do we humans work? What are our values, and how do you actually figure out what millions of people want but can't express? Could we make a machine that could figure that out and either write it down or even try to implement it?
Right. I think this decade itself, there's going to be so much. I think the greatest technological transition, and in that, so many moral and ethical questions are going to be opening up, and we have to deal with it to create a path which is better for us. Earlier during the conversation you mentioned that we could simulate an entire human brain. Would you like to talk about that? What's the possibilities of doing something like that?
So during my PhD work, I was working inside computational neuroscience, and this is where you take computer models of neural systems to try to understand how they work. So a nerve cell is a fairly simple thing. It receives electrical and chemical impulses. It causes reactions that propagate along it, and you can mathematically describe it using a set of equations. You can simulate them on a computer. You can simulate many neurons and see how they send signals, and now you can start comparing that to real biology. So the interesting thing is, of course, where could this end? And you can imagine running bigger and bigger simulation of larger and larger neural systems until you're actually running a simulation of an entire brain. That one probably needs to be connected to a simulated body because brains on their own don't function. You see by using your eye to move your eye around to focus on different things. Quite a lot of our emotions are literally responses from the body. But if you take a complete simulated brain connected to a simulated body in a virtual reality, then you might actually get a copy of the original agent. And of course, right now, this is far beyond what we can do. So we have known the connectivity of a little nematode worm, C. elegans, nervous system since the 1980s. It got 302 or 303 neurons, depending on gender. And then it turns out that we don't know the strength of the connections between these neurons yet. So although we can totally simulate the neurons, we don't quite know how to get the right result because it's a very tenuous system. Instead, people have been starting to work on fruit flies, where a Google project kind of scanned an entire fruit fly brain with about, I think, 50,000 neurons. And that's definitely within the realm of what you could simulate on a big computer. We just need to get more data about the parameters for them. And more recently, there was a paper looking at a cubic millimeter of human brain cortex, scanned it up as a petabyte of data. Now, back in 2008, I wrote a roadmap on how we might go from the current state of neuroscience to a world where you could actually scan human brains and get simulated humans. Or maybe they're actually real humans, they just happen to be software, depending on your philosophical views. Back then, very little of this had been done. We were dreaming about what if one could scan a cubic millimeter of brain tissue. And some people are in the room said, you can never do that. That's too much data. You can't fit it in a computer. And us computer scientists, of course, totally disagreed. And we're feeling rather smug right now that you can totally fit it. But what is happening is that we're getting better and better scanning methods for brain tissue, but we're still somewhat limited. We have computing power increasing radically. Our models of bodies and the virtual reality might or might not be good enough. We still need to bridge this gap, and that's still a big challenge. But I would expect by mid-century, if it's possible, you can start to see the virtual mice running around in virtual mazes. And you can say, okay, that mouse is behaving just like the original mouse that we trained on the maze, and then scan the brain. So in a few years, we are going to do this with humans. That's, of course, a dramatic transition. If it actually works, and that's, of course, a big if, you might end up with software people. And they would, first of all, run at the speed of the computer. So if the computers get better, they get faster. They can take backup copies of themselves. So if something bad happens to their computer center, well, always you can reload them from backup. They can transmit themselves across the internet, even though it's a big file. And of course, you can start thinking about how you can enhance the neural network by actually removing faulty parts or adding extra parts in the simulation. Suddenly, I think the doors to post-humanity opens up quite dramatically. And it's an interesting case because this is one we can actually say a fair bit about, both the technical requirements and philosophical requirements. And you can even think about the economics and sociology of it. The American economist Robin Hanson has written an entire book, The Age of M, about this possibility, where he as an economist thinks about how business would work in such a world. And many people who read it are kind of absolutely horrified, and others are saying, whoa, this is glorious. And I think that's a good hint that this is a book that's somewhat realistic, because if you look at the real world, we have good reason to say this is horrifying, this is glorious, but it's kind of a mix of both things. But could we get brain emulations to work? That would, of course, change the human condition quite dramatically.
Right. Just so interesting. You mentioned about, you would need to think completely, have new thinking in a world like that. But there's something which is already happening right now. There are virtual worlds where there's economies which is brewing. There's something called as non-fungible tokens, where people are buying, selling digital assets on virtual worlds. And that's already happening right now. You mentioned that C. elegans worm is somewhere around just 302 odd neurons. This is something that you guys did long time back. If and when we can do it in a cohesive system where there's no loss of information, whether it's obviously there has to be like a linear process. Right now we said that we be doing it in C. elegans worm, and then we can do it in mouse, and then eventually mammals, and then we can eventually, and you said middle of the century, when we are able to completely scan a functional structure of a brain and eventually be able to upload it on a computer. I'm sure there'll be like moral and ethical implications opening up, because there'll be like a digital copy. What happens to that? But it'll be such an interesting world, because in that world, in that virtual world, you don't need to die, you don't need to fall sick, and you could reimagine and redesign reality as you wish. And that's where virtual reality comes in, and which has already been happening. There are people who are creating world scale simulation. NVIDIA already is building something called as Omniverse. Facebook is building their digital worlds, and we are already laying the building blocks. And eventually, if we can capture the entire functional and structural of what a brain does, then I'm sure we can upload it, and it looks, I'm sure there'll be like a certain section of society which will be saying, why do we need to do that? But, since we've opened up this virtual conversation, Nick Bostrom talks about simulation hypothesis. Are we already living in a simulated world?
Yeah. Once you're open for the possibility that we could make perfect virtual worlds, well, how do I know I'm not virtual? And the traditional philosophical argument about it is kind of skepticism. How do I know I can trust my senses? But the philosopher Nick Bostrom, who is also my boss at the Future of Humanity Institute, he came up with what he calls the simulation argument. He pointed out that, well, if we survive as a species and become advanced post-humans who can run these simulations, then it looks likely that we're going to run a lot of simulations of history because we want to figure out historical questions. We might be running games, we might be setting up fiction. So most minds are likely to be in the simulations. So that seemed to lead to the conclusion that either we are simulated or humanity goes extinct and never does this. Or post-humans, for either it's impossible to simulate humans, or post-humans never do it because they think it's immoral or something. And it has to be all the post-humans for all future history. All of these options sound crazy in different ways. And his point is that at least one of them has to be true. And that is a really interesting thing. Now, in practice, it's a good argument for maybe worrying more about saving the world and maybe seeing, can we coordinate people so we use simulations wisely? Actually believing that you are simulated doesn't change your life very much. Unless you happen to know something about what your simulation is for and what it's intended for, there is no new information here. You just need to go on living your life as normal. If you happen to know that the purpose of the simulation is something, then maybe you can follow that purpose. Or then again, why should you care? If I find that I'm inside a giant simulation that wants to check that the healthcare system of the United Kingdom works well, I don't care about that healthcare system. Maybe I want to keep the simulation running, so I should generate some interesting data in it. But I'm more interested in reading books and being myself. Right. In general, simulation hypothesis doesn't tell you what to do and doesn't change your behavior. So that's why it's intellectually fun, but it doesn't lead anywhere.
But then there's another outlook that you could possibly create a simulated world, with virtual reality, nanotechnology, and your brain-computer interface, and you could possibly lay down the building blocks of a simulated world where reality could be designed. Your own little simulated world, and doesn't need to be the entire, but it opens up. So then there's this another crazy idea which has been floating. The physicist Eduardo Gondelman says that we can build a universe in a lab. It's called Cosmogenesis. When I read about that article, I was completely blown away. Would you like to talk about that, Cosmogenesis?
So the difference here from simulated worlds is that in a simulation, you have a computer that houses representations of the world and maybe its inhabitants. But in this case, we're talking about making an actual physical world. And to some extent, you could say, well, we could do it in space. We could take a bit of matter together and seed a bit of life on it and terraform a planet. But that's not the same thing. This is actually in the lab making what would be a small universe. The reason physicists have been thinking about this is that there are both concepts in cosmology like inflation theory that say that during the early parts of the Big Bang, very small parts of the universe expanded enormously and became the universe we see right now. And then if it happened back then, maybe one could make it happen in the current world. You would need to concentrate a lot of energy in a small area to create a so-called false vacuum. And then under some conditions, that will inflate into a little universe, which is connected to our universe by a tiny little wormhole, which will probably pinch off, and then you have a separate little universe. There is also reasons to think about this when you deal with black holes. One of the fundamental problems in astronomy is what happens at the core of a black hole. The equations seem to say that you get a point of infinite curvature, and the physics and mathematics just break down. Most people say, yeah, at that point, something else has to happen. We just don't know what it is. One proposal is that spawns off a small universe. Instead of it all collapsing infinitely, it bounces back and forms a little universe. Again, we will not get any messages from that universe. We can send matter and energy into the black hole, and it emerges into this universe, but we have no contact. Now, you can imagine that future very advanced particle physics could concentrate enormous energy on small regions of space to make these kind of little baby universes. A real question is, would that allow us to control them? I think personally that is going to be a very random process. Many of the physical laws are probably set randomly, so they could be turning into anything. And I don't think we have much of a chance of sending information to give advice to any future inhabitants, etc. So I think they're going to be relatively independent from us. There is still an interesting ethical question here. Do we think a universe is a net positive? If I could make a universe by pressing a button, should I do that, even though I don't know anything else? And if you're an optimist, you might say, actually, if it emerges intelligent life, it's probably going to make things nice for itself and it's going to enjoy the world. So there's going to be value there. So there's going to be a tremendous amount of value. I should be pressing that button as much as possible. The pessimist says, no, so much pain and suffering. For heaven's sake, don't press the button. Every extra universe just brings more suffering into existence. And we don't know the answer there. This is something that is very worth investigating before we start making universes.
Right. Yeah, exactly. Yeah, because there are these great ideas and questions which is opening up in front of us. Yes, we need to pick and choose, and delve deeper into it and understand it more before we take a step. Since this podcast is from India, would you like to share some advice, or do you have any predictions for India? Because we've all been confined in our home for 1.5 years odd, but I guess that's globally. But would you have any predictions or something for India?
Yeah. So my biggest problem is, of course, I've never been to India. I read about it. I love it.
You should come to India because
I totally want to come over. So I don't claim I understand it at all, but I think India has an interesting position, especially in a world of telework, because India is fairly good with English. And once upon a time, of course, that was leveraged by using call centers, which then leverage, of course, real IT companies. And today, of course, well, the world is connected by telework, which is going to mean that a lot of telework doesn't happen in a given place. And India might be tremendously competitive. The real challenge is, of course, telework also requires an infrastructure that works really well. So I think that is kind of a key question for India. Can India develop a workable infrastructure that's robust and works well enough so one can rely on it? If it can, bingo. Also, of course, since I'm a big fan of democracy and think that China and Russia are doing very bad things to democracy globally, it is good to have allies who actually think that, yep, we should actually care about people, and they are not just serving the state, but actually their lives have value. So the historian Toynbee here in Oxford, in the early part of the 1900s, he wrote this classic book that nobody reads these days about his theory of history and civilizations. And he was also remarking that, the 21st century is the Indian century. He was kind of convinced that the Indian civilization is totally going to be one taking over after the declining Western civilization. I don't think predictions like that work, but I think one should take it as inspiration. I think India has an amazing chance. A while ago, I was watching a television series. It was a comedy cop series set in a future India. They called OK Computer. And I really, really enjoyed that one because part of it felt, of course, a bit alien, a different culture. Part of it was, of course, this human universals about bureaucracy. And some of it is also the human universal, that's how we use and misuse technology in silly, wonderful, or horrifying ways. I think the nice thing is that we get into a world where actually different countries can contribute in so different ways, and we can invent entirely new possibilities. Because that's what I really loved about OK Computer. Some of the things that I would never have thought about in a million years.
I still haven't seen the movie, but definitely, since you mentioned it, I'm going to catch that movie. It's directed by Anand Gandhi, I believe. Yeah, so definitely I'm going to catch it. So what do you think is the future of humanity, post-COVID? Where do you see us going? Are we going into space? Are we going to stay put on Earth? Or like John Smart, he's got this the theory called transcension hypothesis, where instead of going outward, we just go inside into the virtual world, virtual reality.
I think it's going to be a bit of all of the above. I have a hard time imagining humanity doing one thing. Humans do a lot of different things. Yes, we imitate each other. That's one of our great skills. That's how we form societies. And yes, we're very good at making other people do what we want, but we want so many very different things. So when I talk about human enhancement, many people say, no, I want to live in a nice little village, watch people play cricket and have a nice conversation with friends. And given that they want that, it's pretty likely that that's going to continue to some extent. Other people want to go to space. The problem is, of course, space is expensive and dangerous. It's going to take a long while before Elon Musk gets to Mars. But he certainly made space much more accessible. And I think the Starlink satellites are, of course, contributing to integrating the world enormously. So John Smart would say, yeah, those satellites are going to help us towards the transition. We are going to be uploading ourselves, and then we're going to get smarter, merge with machines, and then we're going to say life outside the internet is so slow and boring anyway, and then we all end up in some servers and a farm somewhere, and that's where mankind is hitting quite the humming with solar power. Maybe parts of humanity will do that. I think other people say, yeah, I actually want to explore the universe. Or have their own religious or philosophical or ideological project. What I'm hoping for is an open future where we get to try out all these things. The worst thing that could happen is that we prematurely close the future, either because of a disaster wipes us out, or that you get a world government that just decide, okay, we're done now, we're going to keep this society forever and enforce that forever. That would be just as bad almost as going extinct. But what I'm hoping for is that humanity is going to be like a tropical coral reef, endless diversity unfolding into new dimensions.
Right. Thank you. What a profound note to end on. Really appreciate talking to you. I got into so many topics and you opened up in so beautiful ways. Thank you for being part of the podcast and sharing your insights. And to my listeners, if you like what you see in here, please press the subscribe button. Until next time, see you guys. Bye-bye. Thank you.
Yeah, thank you so much.